Hello everyone, welcome to my channel. In this video I have two questions on algebra that I would like to look at, and both of them are word problems, which means we are required to form equations and solve them. Now, looking at the first one, a boat moves upstream to a destination 12 kilometers away and back in 5 hours. The boat's speed in still water is 5 kilometers per hour, and we're required to work out the speed of water, in other words water current. Now here's the approach to the first one. We are required to work out the speed of water current. So we will let the speed of water be equal to x. So question 1, it says here a boat moves upstream to a destination 12 kilometers away. So we're given distance, and then we're told and back in 5 hours, and the boat's speed in still water is 5 kilometers per hour. Still water is water that's not moving. All right, so the understanding is, as the boat moves upstream, it will be against water current, and so the speed of the boat has to be reduced. Naturally, if water was not moving, this would be the speed of the boat. But because water is moving against the boat as the boat moves upstream, this has to be reduced by the speed of water. And when the boat is moving downstream, this has to be increased by the speed of water, because the water will be pushing the boat down the stream, downstream. So please take note of that. The other thing is the 5 hours, this amount of time, the assumption is this is the time that the boat takes moving upstream and back. Whether someone after reaching the destination had lunch or something, but the 5 hours is assumed to be the distance that the boat is moving. So the approach is as follows. Let x be the water current. It is going to be in kilometers per hour, because that's the speed of water. So these questions are best answered in terms of a table. So we're going to have a table here that looks as follows. Get used to tabling this information. These word problems are best answered using a table, like I said. So we're going to say here upstream and downstream. So I'm going to have that line there with information. I'm going to say upstream, and then I'm going to say downstream here. The first part we are going to look at is the distance in kilometers. If you agree with me, the distance remains 12 kilometers, whether you're going upstream or downstream. This is what the question says. A boat moves upstream to a destination 12 kilometers away and back. So we're told the distance upstream is 12, downstream 12. Next, we're going to look at speed now in kilometers per hour. Speed of the boat here, and at the end there we're going to look at time in hours. There you go. Now, like I said, the understanding here is that as the boat moves upstream, it is moving against water current, and therefore if the speed of the boat in still water is 5 kilometers per hour, going upstream, the speed of the actual speed of the boat is going to be 5 minus the water current. How much is the water current? X. Here it is. And downstream, as you can guess, it's going to be 5 plus x, because as the boat moves downstream, the speed is actually increased by the speed of water. Water will be pushing the boat downstream. Time, where if you remember this formula here, or this triangle, distance is speed times time, and to work out time we have to say distance divided by speed. So distance is speed times time. Time is distance divided by speed. Time is distance divided by speed. So that would be standing for division, and this would be standing for multiplication. Divided by speed, which is what we want. You can also have speed is equal to distance divided by time. But we're focusing on this part here now. So time going upstream, it has to be 12 kilometers distance divided by speed, which is 5 minus x. Downstream, it has to be the same distance, but divided by the speed, which is 5 plus x. We are told that it does that in how many hours? 5 hours. Therefore, it means going upstream and downstream, when we add these two up, we're going to get 5 hours. So we are basically saying, therefore, 12 over 5 minus x plus 12 over 5 plus x, the answer must be equal to 5, because we're told total time is 5 hours. Now we have to solve this equation, where if you look at the denominators, the lowest common multiple of the two values, or the lowest common denominator, will just be the product of these two. So I'm going to take these two, multiply here, there, and there. That's how we solve the equation. So this is going to be 12 all over 5 minus x. Hope you can see what I'm writing here. And then let me put this in brackets now. We're saying multiply this by 5 minus x times 5 plus x, which is our LCD, lowest common denominator, plus 12 over 5 plus x multiplied by the same number, 5 minus x, 5 plus x. And this is going to be equal to, on the right hand side, it's going to be 5 minus x, and then 5 plus x times 5. Remember, you multiply by this, the LCD here, there, and there. Obviously, you can see this cancels that, this cancels that. And so on the left hand side, you're going to have 12 times this plus 12 times that is equal to this. Taking us to page 2, basically I'm saying that what we have now is the following. We now have, on the left hand side, it's going to be 12 times 5 plus x, and then plus 12 times 5 minus x minus x. Let me rewrite this part here, so it's very clear that we're subtracting there. Yeah, 5 minus x, and we're saying this is equal to the right hand side. Remember, it's 5 minus x, and then 5 plus x, and then times 5. Right, so let's work on this then. The right hand side, as you can see, we have difference of two squares there. So that is going to be 25 minus x squared, and we're multiplying that by 5. Please take note of that. Difference of two squares, I may actually remind you that we're saying basically, if I have a squared minus b squared, the answer is a plus b, and then a minus b. Difference of two squares. So you can see that this part here is in the form of a plus b, a minus b, that part. And therefore, we just have to come down there where we square 5 and square x and subtract. But there's 5 outside, remember. So here, expanding, basically, I'm saying, let me move the papers in the right position so that everyone is okay. We can see what I'm writing. The left hand side now is this part is going to be 60 plus 12x. 5 times 12 is 60. 5 times x is, 12 times 5 is 60. 12 times x is 12x, plus 12 times 5 is 60. 12 times x is minus, remember here it's positive, 12 times minus x is minus 12x. And then on the right hand side, multiplying out, 5 times 25 is 125. 5 times minus x squared is minus 5x squared. Right, you can see that cancels that. On the left hand side now, I have 120, because 60 plus 60 is 120. On the right hand side, I have 125 minus x squared. Quite a simple equation to deal with. Adding x squared on both sides and subtracting 120. In other words, take this one to the left and that to the right. You're going to get x squared equals 125 minus 120. Right, I think I'm doing this correctly. That's 120, yes, and there it's oh, that's 5x squared. Sorry about that. It's 5 minus 5x squared. Remember, there's a 5 there. We almost lost it there. You have to be very careful here when you're dealing with these things. So what do we have on the right hand side? On the right hand side, we have 5. Now we have to divide both sides by 5. So that's x squared equals 1 when you divide both sides by 5. Dividing this by 5 is that 5 by 5 is 1. And so we're going to say x is equal to plus or minus square root of 1. We're taking square root. But remember, x is actually going to be 1 positive because speed cannot be negative. Water current cannot be negative. So that would be 1 kilometer per hour. So the answer, the conclusion is therefore the water current is 1 kilometer per hour. This is the water current. Just to check this, if this is correct, you can come back here and check it at this stage. Remember, we're saying x equals 1. So it means, if I may get my calculator here, just to simplify work. Actually, we don't need a calculator in this case because remember, putting 1 here, what is 5 minus 1 is 4. 12 divided by 4 is 3. So there is a 3 there. 5 plus 1 is 6. 12 divided by 6 is 2. What is 3 plus 2? 5. So that makes sense. So our value of x is actually correct. Right, so this is the answer to the first one. Let's quickly move to the second one. But remember how powerful the table is. Tables can be very useful. Let's look at question number 2. You'll see that number 2, our approach is going to be the same. Here's number 2. We are told the cost of feeding people at a party is 28,800, and if one of them had no money or has no money, the others would each pay. If one had no money, the others would each pay 400 rand more. Assume that all the people make an equal contribution. We're supposed to find out how many people there are at the party. So that's the unknown we have to represent with a letter. So I'm going to say number 2, let the number of people at the party be equal to n. The number of people at the party be n. Remember, we're required to work out the number of people at the party. Let it be equal to n. Again, we're going to the table. Using the table approach, especially when you're forming equations, the table, it can be very useful. Now, we have 2 scenarios here. So the first part, I'm going to do this. The first part is when if all have money. All have money. One has no money. We're focusing on the 2 cases. You say, where is this coming from? Where? Here it is where it comes from. If one of the people had no money, the others would each pay for 400 rand more. So now this is the case. Now we're moving to the other side now of the table. We're supposed to look at number of people. Number of people. If all have money, the number of people would be n, because we said let n be the number of people at the party. And the question says, assume all the people make an equal contribution. So that makes sense. All of them have money. This is what you'd have. But if one has no money, the number of people that will be required to pay would be n minus 1, because one has no money. Amount in rands is 28,800. Whether one has no money or no money, the amount stays the same, because that's the amount that's required to feed the people. But now let's look at how much each one pays. We're going to say each pays if all have money, each will have to pay the total amount. And remember, it says here, assume they make an equal contribution. Assume all the people make an equal contribution. So we are now going to say that this has to be 28,800 divided by the number of people. Here it has to be 28,800 divided by the number of people that have money to pay if one doesn't have money. Now, which of these two numbers is greater? The question tells us that if one has no money, the remainder, the others would pay 400 rand more each. So remember, each pays this amount when one has no money. Each one pays this amount when when all have money. So it means that this one here is actually 400 more than this. Please understand there. That's where the trick is. Here it says, if one of the people had no money, the others would each pay 400 more. So this is 400 more. That means if I subtract 400 from this, I must get this. Or if I add 400 to this, I must get this. So we're going to say, therefore, 28,800 over n. We add 400. The answer must be the same as 28,800 all over n minus 1, where the trick is. Now let's solve this equation. Again, the lowest common denominator, LCD, is the product of these two. So I'm going to now say n times n minus 1 times 28,800 over n plus n minus 1 times 400. Remember, you multiply by the lowest common denominator. Every term has to be multiplied by the same. And on the right hand side, I'm going to have this number here, which is 28,800 all over n minus 1. I multiply this by n minus 1, like that. We multiply by the same constant everywhere. Now this cancels that, and this cancels that. So on the left hand side now, I'm going to have n minus 1 times 28,800 plus this part here is going to be 400n times n minus 1, multiplying those two. And then on the right hand side, you just have 28. Remember here, I cancelled only the n minus 1 and not the n. I cancelled only the n minus 1, not the n. So basically, I'm saying on the right hand side, you have 28,800n. 28,800n. Let's solve this equation by simplifying it. So taking us to page 4, hopefully we can manage to complete it here. So basically, I'm saying expand that 28 multiplied by this 28,800 multiplied by these two terms. It's going to be 28,800 n minus 28,800 plus, expand this out, it's 400 n squared minus 400 n, and then on the right hand side we're going to have 28,800 n. Now you can see that you can subtract this from both sides. On the left hand side, you're going to have 400 n squared minus 400 n. This one and that one is gone, but we have minus 28,800 is equal to 0 there, because this is gone together with that. So you're left with 1, 2, 3 terms. These are the ones here we have. Now let's simplify this equation. What do? We'll divide by 400 throughout. If we divide by 400 here, we're going to get n squared minus, there is going to be n minus this number by 400. The 2 zeros will cancel those 2 zeros, and 4 into 28 is 7, into 8 is 2, so this is 72, and the answer is 0. Factorizing this, I have explained the story of factorization, but let me take you through the process again. What we do is, if you allow me to use a different color, we take this term here, multiply by that term. So the answer is going to be, let me write it here, it's going to be minus 72n squared. That is known as the product. And then we are looking at the sum of, this is minus n, which is basically minus 1n if you like. And sorry, I'm going to write minus 1n here because I need to write sum in that space, product sum. Now take note of this, that what we're looking at now, or looking for, are two factors of this expression. Whose sum is that, and whose product obviously is that one. Counting, we start from 1. We start from 1, counting 1. 1 into 72, the answer is 72. For someone who doesn't know how to approach it, this is what you do. But now, because that sign is minus there, the product is minus. The signs here are different. Please take note of that. The signs are different. One is positive, the other one is negative, because minus times positive is minus, positive times minus is minus. If I had a plus sign, they would either be minus both of them or positive both of them. So adding this up, because we're saying we're interested in the sum, I'm going to write when it dries there, we're interested in the sum, so we add these two up. The answer is going to be positive 71. Adding these two up is minus 71. Moving from 1, naturally when you're counting, you go to 2. 2 into 72, the answer is 36. The signs must be different. Adding this up is 34. There, minus 34. From 2, we're moving on to 3. 1, 2, 3. Can I take 3? Yes, 3 into 72. I think it goes in there 24. Yeah, let's take 3. 3 into 72, 24. The signs must be different. Adding this up, the answer is going to be positive 21 minus 21. Can I take 4? Yeah, 4 into 7 is 72. It's going to be 18. Yeah, 4 into 72, 18. The signs must be different. Adding this up, the answer is 14. There's minus 14. Now from 4, I have to go to 5. Can I take 5? 5 doesn't give me a whole number when I divide into 72. It means I must move to 6. Can I take 6? Yes. 6 into 72, the answer is 12. So the signs are different here. When you add this up, the answer is positive 6. There, the answer is minus 6. From 6, I'm going to 7. Can I take 7? No, because 7 doesn't go into 72. Can I take 8? Yes, I can. 8. 8 into 72, the answer is 9. The signs must be different. When I add this up, the answer is positive 1. When I add this up, minus 1. And that is what I'm looking for. There it is. So we're saying here, these are sums. I'm looking for minus 1, which I've got here. So each term here has to have an n. So I must put an n there. N, n, n. This is what we have there. So these two terms must come in the center and place minus n. So let me move back a little bit. Hopefully you can see. Yeah, you can. So I'm going to have n squared. Instead of minus n, I'll have positive 8n minus 9n, these two terms, and then minus 72 is equal to 0. And I combine these two terms. The common factor there is, remember, n, open brackets, n into n squared, n into positive 8n is positive 8. My common factor there respecting this sign is minus 9. Minus 9 into minus 9n is n. Minus 9 into minus 72 is positive 8 is equal to 0. So common factor, as you can see, is n plus 8. N plus 8 into that, the answer is n. N plus 8 into that, the answer is minus 9 is equal to 0. Therefore, either n plus 8 equals 0. Solving this gives us n equals minus 8, and this is not applicable. Why? Because n must be a natural number. Number of people cannot be negative. Remember, n is the number of people at the party. What about the other part? Or n minus 9 is equal to 0. What is n equal to? 9. So, therefore, there are 9 people at the party. There are 9 people at the party. That's our conclusion. We will do a bit of checking here before we run away. So this is the only sensible answer. Let's go back and check. Coming back here, we're saying n equals 9. If you put 9 there, it's going to be, let me just use the calculator because of time. We're saying 28,800. 28,800 divided by 9. The answer is 3,200. Add 400 plus 400. The answer is 3,600. So the left hand side will be 3,600 for n equals 9. What about the right hand side? 28,800 28,800 all over 9 minus 1. Obviously, you can see 9 minus 1 is 8. Divide, there you go, 3,600. So it makes sense. 3,600, 3,600. It means n equals 9 is the correct solution because it satisfies the equation here. All right, I'm going to stop here in this video. If you're new to this channel, please support us by subscribing, sharing these videos, and providing comments. Your feedback is absolutely important to us. All right, I'll stop here in this one.